Hello my friends and welcome back to the channel. I know it's been a little while since I posted anything, but I recently moved and my new office in my new house is a little bit echoey, so I apologize if you hear a little bit of a reverb here. I've been trying to minimize it, but ultimately it's proving to be a little bit of a challenge. But that said, I want to talk to you guys today about 3 tools that are going to help you deal with messy meta-analysis data quickly and easily. These are all things I really wish existed back when I started doing meta-analysis, okay? So the first and foremost, we're going to talk about the Practical Meta-Analysis Effect Size Calculator by Dr. Wilson. This has been out for quite a while in different forms, but it is very, very effective and very helpful. So oftentimes we need to actually calculate an effect size from our study. Maybe they didn't report it in a way that we want. So like maybe the study reported just the F statistic from an ANOVA, but we actually want the Cohen's D. What can we do? Well, we can do a lot of math, or we can go use one of these calculators. So here, as you can see, if I hover over the Cohen's D and Hedges G button, we have a number of options. So you can see if we have t-test results, but we need to calculate a Cohen's D, we can do that. If we have ANOVA results, but we want to calculate a Cohen's D or a Hedges G, we can do that. So this tool is wonderfully helpful for calculating any sort of effect size quickly, easily, and accurately. So as I mentioned, they have a number of different, what I would call like effect size families, where we have Cohen's D and Hedges G, we have odds and risk ratios, we have correlations, and then finally we also have the formulas that are used to calculate each one of these things. If you really love stats, you can go dig into all these. Sounds like my idea of a Saturday right there. So yeah, if you really want to see the stats and how it's calculated, it's right there. And I will say, I do encourage everyone to, when you're first learning statistics, learn about how these things are actually calculated. Way too many times we're like, oh, there's a calculator, I don't need to understand it. You really should understand it, okay? You really should understand it. So if you haven't looked at the formula that you're actually using, go take a look at it, understand it, and then go use the calculator. So, second one that I wanted to show you is something I just found today, and it's the whole reason I decided to make this video, despite my frustrations with the room being echoey and me not having fully solved that yet. And this is this website called Meta Converter. So, in all honesty, I found this morning, decided to make the video, and that's that. I have not tested this yet, in the sense of I have not actually gone through and hand calculated these things to make sure that what it's calculating is accurate. I trust that you will do that on your own, the same way that I will do that on my own before I use any of these. But that said, one of the most common things I run into in meta-analysis, one of the most frustrating things I run into in meta-analysis, is when authors don't give me the right data to make it really easy to get the statistics that I want. I know, that's pretty selfish, right? But it's true. So in my field, one of the most common things I encounter is the authors have given me standard errors, but I actually want standard deviations for my coding form. Now in the past, I would use a formula and I would use like Excel or something and I would calculate this. But now it seems like we can use this site MetaConverters to do it for us. So when I open up their tool for this, you can see here, all we have to do is enter the standard error for the group. Let's say 5. And then the sample size of the group, let's say 45. And then I go over here and hit calculate and it gives us an answer. Now, is this answer accurate? I'm going to assume so for the purposes of this video, but as I mentioned before I use this tool, I will be doing the math to actually check, and I would encourage you to do the same. So there's a number of different tools here on their site. So I'm going to go back here and you can see they have a whole bunch of different tools to help you convert between different statistics. So what I would suggest you do is, if you are interested in using this, go through, calculate what it says. It says here it would be 33.541. Then I would do the actual formula that I know to convert between a standard error and a standard deviation and see if I come up with the same answer. And then if I do, I know that I can trust this tool. Now, one of the things that I want to mention here is that I don't only suggest trusting it just because it's this tool, right? There's nothing against this particular tool. Any web-based tool you use to calculate things for statistics, for your academic papers, you really should take the time and hand calculate it to make sure that you know you can trust it. Okay, so please don't think I'm saying that only about this site. I say that about any web-based tool that you use. Heck, even if you're using my tools, like the meta-analysis software I created, look into the R code and then try and replicate it in R and make sure that it's giving you the results that you are expecting to receive. You should always do that when using web-based tools. It doesn't matter who the creator is. You should always make sure that you're getting the results that you expect to get before you fully trust one of these tools. Okay, now one of the things that I liked about this site, and one of the reasons I wanted to share it with you, was the third thing that we can do to help make dealing with messy data better. And it actually brought me to the site when you click on formula reference. So number one, I like that they reference the formula that they use. To me, like major thank you to the author of that website who did that. So you can see here it linked to the Cochrane training handbook. And this in itself is an awesome resource for you. Okay. So the nice thing is this old version of the handbook, it is not behind a paywall. It is not even behind a login wall. Anyone can access it at any time. And that is awesome. This is what I actually use when I'm trying to get the formula to convert between different things. So you can see here, they have what the standard deviation is equal to standard error times the square root of n, right? So in the past, before these online tools were created, I would go to this handbook, I would look up the conversion, and I would do the math myself. But now we have really cool tools that can help us do this much faster. Okay, so last but not least, I just want to show you that this entire handbook is available to you online. I'm going to include a link to it, okay? But you can see, if you are looking for training in meta-analysis, this handbook is super helpful. So in just dealing with messy data in particular, I'm going to go back a little bit in the handbook to this desired format, right? So you can see they have tips for dichotomous outcomes, continuous, ordinal, count, time to event, and estimates for effects. So all sorts of really truly useful things. I primarily use continuous outcomes in my work. So I'm going to click on that one, and you can see we can talk about obtaining standard deviations from standard errors and confidence intervals. We can obtain standard deviations from confidence intervals, t-values, and p-values. There's all sorts of really helpful formulas and conversions in here. I'll just click on another one so you can see the general layout of the site. But you can see, what if we need to go from a t-value to a standard error? Well, we can do that. It gives us the ways to do that, right? It gives us the formulas. So super powerful. These are 3 tools that I think will help you. They're 3 things that I wish existed, at least, or I should say, I wish they knew they existed when I first started in meta-analysis, maybe 10 years ago or so. First is that practical meta-analysis effect size calculator by Dr. Wilson, I believe. Yep, by Dr. Wilson. I actually have been using a version of this for a very long time. It is a wonderful resource in my opinion. The second one is this meta converter website that I just found today. I think this will be very useful into the future as long as the math checks out and the conversions that I use are actually accurate, which I honestly expect them to be, especially since they're linking to the Cochrane handbook. I expect they're going to be, but I'm going to check it before I use it in my own work, and I would suggest that you do the same. And finally, our last tool that you'll find very helpful, I think, is the Cochrane handbook that is available online for free, no login required, and no paywall. So I will include the link to all 3 of these things in the description. I hope this video has been helpful for you, and I hope you guys have an absolutely great remainder to your day. If this has been helpful and you like this content, please like and subscribe to help support the channel. Thank you all, and I hope you have a wonderful afternoon.